How do I score fuel in Rebuilt? In Rebuilt, teams need to put the fuel ball into the hub. Because the opening of the hub is quite a bit taller than the robot's max height, they're going to have to look into ways of launching the fuel into the hub. Fuel is a nearly 6-inch diameter ball made of high-density foam and has a nice outer coating. It's fairly slick, which makes it easy to move game pieces around in your robot, but also launch. So Rebuilt's a really exciting game. Due to the sheer number of game pieces on the field this year, and the lack of a holding limit on a robot, we think that we're gonna see a lot of high-paced action. We've had a lot of different launchers over the years for first games, but due to the nature of Rebuilt, we think a wheeled launcher is going to be very effective in this year's game task. Part of this is gonna be based on how easy it is to load a wheeled launcher, as well as the ability to change settings to make it work from various different locations. Let's kind of walk through what a typical launcher looks like. At the front, we have some bearings to make a very smooth running flywheel. Looking at the flywheel, we see on this particular one, we chose these orange stealth wheels, but inside the stealth wheels, we've mounted our flywheel weights. This is pretty useful because it increases the rotational momentum of the flywheel so that it doesn't slow down as much as you're feeding game pieces through. This will be pretty important, especially if you're trying to put multiple game pieces through at a given time. So there's a lot of different options for wheels that you can put on a flywheel-based launcher. Our stealth wheels have a very consistent, smooth outer profile, which means you're gonna get a consistent contact as the game piece is in contact with the wheel. And those come in a lot of different varieties, including diameter, which is gonna change the overall speed, or the durometer, which is gonna change the interaction between the wheel and the game piece. Every wheel-based launcher needs some form of power input. And in this case, we have space for 2 different locations where you could mount a motor. In this particular case, we're using a belt to drive the main wheel from a Neo. So generally speaking, a flywheel-based launcher needs the wheels to be spinning at what we would consider a faster speed. So to do this, we're using a 1-to-1 ratio off of a motor because that's gonna give you a higher surface speed. One neat feature about this launcher kit is because there are 2 motor inputs per side, you can have a larger number of overall motors driving your system. And depending on your setup, having more motors may allow you to put more game pieces through the robot in a given period of time. So as you might think, being able to put game pieces into the hub at a fast rate is going to be important for this year's game. In this setup, we have a single fuel wide setup, which allows game pieces to go through single file. If you expand it to be wider, you have more ability to put game pieces through the system at the same time, which could increase your throughput. You might have more spread of game pieces and have to factor that in with the size of the hub. Luckily, the hub is fairly forgiving, so you can probably get away with having a larger or a wider version of the launcher. So our side plates will make up the main structure of our launcher. And as we look at it, we see the holes along in the different groupings to help you set everything from launch angle to the amount of compression for your game piece. You may find you need a little bit more compression in different areas. If you're not able to achieve that with the different settings on your launcher, you may find it's easy to add this rubber adhesive backed foam to the various areas around your robot to increase the compression. This stuff is really nice because it has an adhesive back to it, making it easy to just stick into place. And it's got a nice foam rubber texture to it, which can provide either more grip, which can change spin, or it's got a little bit of compliance, which might make it easier to fit game pieces through. So with our different groupings, each one of these is 22.5 degrees apart from the previous grouping. Now what this allows you to do is set your angle based on where the hood ends to get either a flatter shot with a more high release or a more arcing vertical shot by making your release lower. Closer to the hub, you might want a steeper launch angle because you need to be able to get the game piece above the height of the funnel. From farther away, you might find that you need a shallower release angle because that will allow you to get more horizontal distance out of the ball. It may be important for your robot to be able to change its hood angle while it's moving around the field, especially if you want to launch from multiple locations. So with most launcher-based devices, there's 3 different ways that the ball can move through the air. There's with no spin, there's with topspin, and there's with backspin. In a system like this, as the ball goes through and follows the curve, oftentimes it'll generate backspin. Now what backspin will do is when the ball hits a target, it'll oftentimes kick backwards towards its point of origin. Other launchers might induce topspin on the ball. When a topspin ball hits a surface, it oftentimes tries to kick away from its point of origin. No-spin systems generally react like a knuckleball through the air and typically have a neutral effect when they hit surfaces. As with any launching game, aim is going to be super important. So one really easy way to aim your robot is using the field structures itself. There's a lot of field structures that are perpendicular to the goal, which should make it really easy for you to run into them and cause the field structure to align your robot so that you're already aimed at the goal correctly. If you look at the front face of the hub, it's completely flat, which makes a good spot for your robot to run into and set your spacing and your distance away from the goal. Using some of these field locations makes your robot in a very predictable and consistent location. This should help you tune in the other factors of your launcher, such as the speed and the angle. Another method you can use to aim on this year's field is being able to rotate your output to face the goal. This is our new turret kit with the launcher mounted on top of it. And what this does is it allows you to change which direction your launcher is in relation to the rest of your robot. So a turret can increase your flexibility when aiming for the goal by giving you more locations in which the robot can be, as well as more orientations that your robot can be and still be aimed at the hub. So in each corner of our turret kit is an input which takes a 20-tooth gear to drive this larger 200-tooth gear. By having a gear reduction here, we can get pretty precise control over the direction that our launcher is facing. There are a lot of different ways teams will find to be able to home or know where their launcher is facing at any given time. If you're using a brushless motor on the input of your turret, you can use the internal sensor on your motor to determine how far it's rotated from a given spot. One trick we've seen over the years is starting with the turret in a known location and then using the delta and how much you've moved from that location to determine where it is. In this case, we have a mark on the turret base plate and we have a mark on our output to know where to start it at the beginning of a match. Other things you can do include absolute positioning. This can be done by mounting an absolute encoder to the turret kit to track the overall position regardless of which way the robot was aimed at the beginning. Be sure to check out our assembly guide for more information about using sensors with the turret kit. On the field this year, there's a lot of April tags. And April tags are really useful because they provide information back to the robot about its positioning. Oftentimes, we see teams with different aiming devices on the robot, such as a turret, will mount cameras to their robot for tracking the April tags. This information could be useful to provide the distance you are from the goal, and that might be worthwhile to change stuff like your hood angle. Additionally, the angle from the target can be useful for reorienting your mechanism. There are a lot of really great resources out nowadays, from everything between robot design to code to wire management. Be sure to check out these community resources to help you make informed decisions on your robot design. As always, read the game manual, ensure you know the game, and we hope to see you out there. And that's how you score fuel and rebuild.